Hello students, good morning to everybody. How are you? Today we will discuss about isosceles triangle, an important and interesting topic of your geometry part. We know in our previous videos there are three types of angle, three types of triangle: scalene triangle, isosceles triangle and equilateral triangle. Now today we will discuss about isosceles triangle. What is isosceles triangle? At least two sides are equal is isosceles triangle. No sides equal, scalene triangle. All sides equal, equilateral triangle. Today we will discuss about isosceles triangle, part 1. Now we know that isosceles triangle has two equal sides. We have to prove two equal angles opposite to them. If two sides of a triangle are equal, then the angles opposite to them also equal. We will prove that theorem. Our congruence chapter already covered up. By using congruency of triangles, we can prove, we can find out anything else in geometry. Geometry makes easier 90% while we knowing about the congruency of triangles. Now we will prove how, if the two sides of a triangle are equal, how the angles opposite to them are equal. Now let us write that theorem. If theorem 1, if two sides of a triangle are equal, then the angles opposite to them are also equal, are also. There is no need to write the theorem, because if you understand the gist of the theorem, we can explain in our language. If two sides of a triangle are equal, then the angles opposite to them are also equal. Now here is a triangle. ABC is a triangle. Two sides equal. Suppose AB is equal to AC. So opposite angles, B angle is opposite to AC angle and C angle is opposite to AB angle. We already discussed the basic knowledge of geometry, basic knowledge of a triangle. So if two sides equal, then angles opposite to them also equal. Our statement or theorem tells us what is given point, what is to prove. Most important thing, our theorem, our statement, our question tells us what is the given point and what is to prove. So given in ABC triangle, two sides of a triangle are equal, that is a given point. AB is equal to AC, and to prove Angle B is equal to angle C. Angles opposite to them, the AC opposite angle B and AB opposite angle C. Angle C is the opposite to AB, angle B is opposite to AC. So angle B is equal to angle C. We have to prove. Here is a construction. Draw a perpendicular. Draw AD perpendicular to BC. Draw AD which is perpendicular to BC. We know perpendicular, height, distance and same things, altitude. The AD perpendicular to BC. Now proof. 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 To prove. This is 2 plus infinitive verb. PROOF prove is noun. So prove. Now look, ABC triangle now divided into two right angle triangle as AD is perpendicular to BC. Then ABC triangle divided into two parts, ABD and ADC. Now we compare the two triangles. In triangle, very simple, very easy. In triangle ABD and triangle ADC. In triangle ABD and ADC, first AB is equal to AC. First point, AB is equal to AC, that is given. Second, ADB, angle ADB is equal to angle ADC, that is equal to 90 degree. What is this? This is construction. Due to construction, as AD is perpendicular to BC, the first thing AB is equal to AC. In triangle ABD and triangle ADC, AB is equal to AC, ADB is equal to ADC, that is equal to 90 degree construction. And then next thing, AD is equal to AD, that is common. I always said that every step of a geometry has a region. We should write the region on the right side. That's why our step was right. So side angle, side angle, this side, AB is equal to AC, AD is equal to AD, and this angle is equal to this angle 90 degree. So look, here this is 90 degree, this is also 90 degree. The side opposite to 90 degree angle or right angle is hypotenuse. We already discussed more examples, so many examples, so many theorems. So AB is hypotenuse, this is hypotenuse, this is right angle, this is right angle, this is side. So the two triangles are congruent. Triangle ABD congruent to the triangle ADC due to which reason? Right angle, hypotenuse and side, RHS. We know in congruency theorem, congruency chapter, there are 5 conditions satisfy the congruency. The RHS is the one of the condition. That's why the two triangles are congruent to each other, right angle, hypotenuse and side. So then after congruency, the rest part of the triangles are equal. So angle B is equal to angle C. Angle B is opposite to AD side. So AD is equal to AD. The angle opposite to AD is C. So angle B is equal to angle C, proved. So many problems, so many theorems are to be proved by using congruence triangle. So congruence triangles, 5 conditions are main conditions in geometry part. If you don't see the congruency theorem, congruency condition, please see the congruency video regularly and note that video, and that's why you will understand better the further examples or further exercise or further theorems. So this is the theorem 1. What is our theorem 1? If two sides of a triangle are equal, then the angles opposite to them are equal. First given, we drew a triangle ABC in which AB is equal to AC. To prove angle B is equal to angle C, then it has a construction. Let draw AD is perpendicular to BC. Then we take two triangles, two right angle triangles, ABD and ADC. In ABD triangle, AB is equal to AC given, and ADB is equal to ADC, that is equal to 90 degree, and AD is equal to AD. So triangle ABD is congruent to the triangle ADC due to RHS. Then after congruency, rest part of the triangles are equal, but we have one part, that is angle B is equal to angle C. So angle B is equal to angle C. And take a look, if angle B is equal to angle C, we conclude that angle B is equal to angle C, then angle BD is equal to DC. Also BD is equal to DC. This is not our part of the theorem, but it is the conclusion. It is a corollary. BD is equal to DC. Again BAD is equal to CAD. BAD is equal to CAD. This is proof. This is another thing. This is a third thing. Three things, three components are equal. That's why we do triangle, two triangles are congruent. Rest part means rest three things are also equal, which is one side, two angles. Angle B is equal to angle C, which was our proof, but angle BAD is equal to angle CAD. This angle is equal to this angle. This side this is equal to this side. I am telling this because it will be most turning point in your future or next questions, next problems. So let us go to take a screenshot, then we go to the next theorem, just reverse of theorem 1. Theorem 2, if two angles of a triangle are equal, then the sides opposite to them are also equal. This is the next theorem, just reverse of the theorem 1. If two angles of a triangle are equal, then the sides opposite to them are equal. Then draw a true triangle, one triangle A, B, C. Now here two angles are equal. So given point angle B is equal to angle C, just reverse of theorem 1. Then sides opposite to them, so to prove is equal to AB is equal to AC, because angle B opposite side is AC, angle C opposite side is AB, so AB is equal to AC. Then construction, same construction, that is equal to draw AD is perpendicular to BC, AD is perpendicular to BC, D, AD is perpendicular to BC. Then prove. This is our theorem tells two angles are equal, that is given point, two sides are equal, that is to prove, and construction AD is perpendicular to BC. Now take two triangles. In triangle ABD and triangle ACD. In ABD triangle, ADC triangle, this angle is equal to this angle, that is given. Number 1, I, angle B is equal to angle C, given. Then second, angle ADB is equal to angle ADC, that is equal to 90 degree. It is also construction, due to construction. Then triple I, look, triple I, AD is equal to AD, two angles are equal, this angle is equal to this angle equal to this angle, two angles, and one side, we know the congruence chapter, AAS, two angles are one side of one triangle are equal to two angles and a corresponding side of another triangle, then the two triangles are congruent to each other. Congruence chapter is very, very important. So this angle is equal to this angle is equal to this angle, AD is the corresponding side, because the AD is opposite to B angle, also AD is opposite to C angle, so AD is equal to AD common. So triangle ABD congruent to the triangle ACD due to AAS, angle corresponding side. So two triangles are congruent to each other. So rest part of the triangles are also equal. What is the rest part? Take AB, in ABD triangle AB, so AB is equal to, the AB is the hypotenuse, so the hypotenuse the other triangle are also equal, AB is equal to AC, that is proof. So this is the proof, and rest part you can also try to write, the rest part of the triangles are also equal. So for this isosceles there is two theorem we already studied, and in isosceles triangle there are so many turning points in isosceles triangle. Isosceles triangle, now take a screenshot. Another small thing, a triangle has a three angles, three sides, three median, three perpendicular, three vertices, also three bases. A triangle has a three bases. Every side is a base. Now look, this is isosceles triangle. ABC, AB is equal to AC. AB is equal to AC. But a triangle has a three base. I would teach you the base in your area chapter, but here you know a triangle has a 3 bases, 3 sides, 3 angles, 3 perpendiculars or 3 heights, 3 medians, 3 angle bisectors, 3 side bisectors, and 1 incenter, 1 circumcenter, and 1 centroid. So ABC is a isosceles triangle. In isosceles triangle, in generally except equal sides, the third side is generally treated as the base. So it will be treated as the BC base. BC is the base. In isosceles triangle, BC is the base. BC is generally treated as a base, but that not means a triangle has one base. A triangle has 3 bases, but in isosceles triangle, generally BC taken as the unequal side is generally treated as the base of the isosceles triangle. It is very, very important for your construction and other proof deduction. It is very, very important. Isosceles triangle, the third side is generally treated as the base. So if this is base, this is perpendicular, this is perpendicular. So we know isosceles triangle. In isosceles triangle, perpendicular is the angle bisector, because we just proved this angle is equal to this angle, as this side is equal to this side. So this is AD is also the perpendicular bisector of BC. AD also what? Perpendicular bisector of BC. AD also bisector of angle BAC. This is the corollary things, but more things we know. In of isosceles triangle, vertex is the opposite of third side. Vertex generally opposite to the third side, but a triangle has 3 vertices, and the base of the triangle here of an isosceles triangle is the third side is the base. General we will take BC is the base, this is the perpendicular. So in the next video we will study the more problems relating to isosceles triangle. They are angles, perpendiculars, but always try to remember the conditions of a congruency triangle, the 5 conditions of a congruency triangle. For today, this much. Thanks. Goodbye.